So, look, there is a largest trend, in particular in Europe, in terms of power availability, right? We're seeing grid connections now across most European markets taking anywhere between 6 to 8 years for a data center to get a grid connection. That's today. With AI and the increase that AI is going to be bringing uh, to basically the power demand, we are seeing that we're going from I think it was the end of 2024, 61.5 gigawatt global data center power demand to 219 gigawatt by 2030 being data center driven, right? Now, if you look at that, just because of AI and AI driven applications, like, for example, machine learning, inference AI, training AI, um, that's going to be putting even more strains onto the grid, right? So, on one side, you have the data centers having issues to get connections already. On the other side, we're seeing a massive demand in new power and power generated for these type of applications. The data centers now are seen as citizens of the grid, right? They have to interact with the grid. And we're trying to, on the Eaton side, come up with what we think is the perfect definition for a data center to be a good grid citizen. So we have about, at the moment, 8 criteria that really talk to, hey, look, if you have a data center and you're going to be cooperating with the grid, you need to meet these type of criteria to at least be able to define yourself as a good grid citizen. We're talking about energy efficiency, basically implementing features and strategies that reduce the total energy load of the data center into the grid. We talk about peak shifting or load shaping, which is really adjusting the timing of energy use to avoid peak demand during periods where other areas of the grid are also going through that peak demand. Dynamic demand response is another key criteria. So, do you have the ability to reduce energy in response to short-term grid constraints? So, how can the data center make sure that uses power during the best hours of the day, and it eventually reduces power? And when we talk about, for example, training facilities, at what time are you running models? And is there a better time, right? Is there a better time when you need to be running and going at 100% of your compute power capacity? The fourth category for us is around renewable energy integration. So how does the data center integrate renewable energies as part of the overall power consumption? And is the data center able to provide fast frequency response, right? So we were running, for example, some numbers, and if we look at a 1% gain in efficiency for a 1 megawatt UPS, that's about 10 kilowatt. And if we look at the total greenhouse emissions of those 10 kilowatts over a year period, we are talking about 2 million kilograms of greenhouse emissions. If we compare that to UPSs that are able to do fast frequency response as being part of the grid, we've seen market research out there that talks to having a UPS with fast frequency response being 100 times more efficient in terms of the reduction of carbon emissions, right? So it is important also for data centers to have UPS that are facilitating the data center being a better grid citizen. We're talking about dispatchable energy storage. We're talking about strategic collaboration with the TSOs and the regulatory bodies. We are talking about grid sensitive designs. We're talking about giving back to the community as well. So, for example, are you reusing the heat that is generated by the compute to do district heating, right? Is that part of the rollout? Is that part of the plan? So there are quite a lot of different criteria at the moment that are need to be considered for data centers to really be interacting with the grid, but also being a good grid citizen. So there is quite a lot of stress at the moment, right? And it's basically because the discussion is not really just about data center. You really need to have, we call it the four legs of the stool, right? Which basically is you need to have the regulator and the TSO and the investor and the data center operator really talking and setting the boundaries of, look, this is how we want to operate, and this is how we want to be able to supply and support all this power generation, all the regulatory points that are really out there at the moment. So we are seeing a lot of work at the regulatory level as well. For example, a data center at the moment cannot just produce their own power on site. It cannot be on what we call island mode on site power generation. So what we're seeing is that there are regulations out there that are really forcing the data centers to provide unconditional dispatchable energy back into the grid. So there is more than one people in that discussion, right? And so people is now trying to, on one side, create a very competitive environment for Europe and EMEA in general to be able to ride the AI wave. On the other side, there are a lot of regulatory requirements that also need to be complied with. So I try to answer this question with two different points of view. So one is the kind of the current regulatory framework that is in place, and I talk about particularly in Europe. So the European Energy Efficiency Directive is now setting up guidelines for data centers, and there are guidelines around metrics that the data centers need to comply with. Some of these metrics are like the usual suspects, like PUE. But then the directive and the guidelines are going a step further in terms of the ERE, the energy renewal effectiveness, right? Which measure how much of the power consumed by the data center is coming from renewable energy sources. And other guidelines around measuring, for example, the heat reuse effectiveness. So what percentage of the heat that is generated by the data center is being reused, again, for applications like district heating. And we see that in some countries in Europe, some of these some of these guidelines are being put into legislation. For example, in Germany now, we are seeing the ERE metric, the energy renewable effectiveness metric, and putting the data centers at 100% of renewable energy usage by 2027. So we are seeing a lot of different regulatory requirements being pushed into the data centers. Now, on the other side, and the other side of the equation is this regulatory framework, that means the regulation that is being put in place, really helping create a competitive environment in the scope of the AI race. And I think that's where we probably need to do more. That's probably where we need to spend more time as Eaton, because we have the efficient power distribution components, critical power components, and we have UPSs that are grid interactive, that can support the data center become, as we were discussing, better grid citizens. But the TSOs need to be involved, the data center operators need to be involved, and the regulatory body really needs to help in creating that better competitive environment at the European level for us to really be able to gain positions and eventually be at the forefront of the AI development that we're trying to go through. I think it could. I'll be more concerned about the availability of power really being what acts as a hindrance in terms of AI and data center development. But if we look at the overall availability of power, not just for data centers, and the increase in the price of electricity, it will obviously have an impact in the economics and the overall business case. And that's why earlier I referenced on the investor side. I think it's important for investors to also be at the table and understand the efficiency roadmap of a data center, to be able to quantify that into the economics, into the business case, and see if it makes sense for them to really go through with the project if the energy prices keep increasing. I think that's something that at the moment is a question mark, but it could potentially be an item that hinders that development. Yeah, so look, I'll cover a couple of points. One is, and I mentioned earlier around the metrics, right? PUE is a universal metric at the moment, I think, that everybody understands. So it has served its purpose, right? Everybody now that talks about a data center talks about PUE. The issue with PUE doesn't really measure how efficient power is being used in terms of output. So if we look at data centers, really they consume power to generate data outputs, right? Whether it's in tokens, in flops, in megabits per second, moving data around the different servers. And there has to be a metric that I think establishes how efficient that power is being used to increase the number of tokens and to increase the number of flops of calculations. And that for me, I think is as an industry, is probably one of the areas where we can develop a new metric over the next couple of years that is really looking at the actual efficiency of compute power. And then obviously there has to be metrics around power and power usage, efficiency around power and compute power inside the white space. But all in all, I think we have to migrate to new metric. That for me is one of the areas that obviously we can do better on. And then look, I'll encourage everybody to visit the Eaton's website to look at our energy-aware UPSs and how they can really help, on one side, operators, data center operators, be better grid citizens, but on the other side as well, to TSOs to really look at the fact that there are products out there that are helping data centers provide fast frequency response for write-through mechanisms that eventually really help mitigate some of the negative impact of AI loads into the grid. And I think if they can spend a little bit of time going through that documentation on the website, I think they can learn a bit more about the next generation of UPSs.